So in the last video, we looked at the basics of U-substitution. In this video, let's look at some more examples, some more complicated examples. So let's take the integral of x times x squared plus 2 raised to the 6th power dx. Now there's a lot going on in this problem. We have x squared plus 2 inside the parenthesis raised to a 6th power, and then we have x on the outside. Without using U-substitution, it would be really hard to integrate this problem. And how do we use U-substitution in this case? If you look at the inside, we have x squared plus 2. If you set that equal to u, and you take the derivative of that, du is going to equal 2x. And we have an x term, so that's how we know the inside is going to be what is going to equal to u. So u equals x squared plus 2. Now du equals, you just take the derivative of that, 2x, and the derivative of a constant is always just 0, so we don't have to write that, and dx. But now we have one problem. We have x dx over here, not 2x dx. So to make it equal to that, what we have to do is divide both sides by 2. And then we have du divided by 2 equals x dx. Now we can just rewrite the problem as integral of u to the 6th du. And we can just bring the half on the outside since it is just a constant. Now if you look at this, it's equal to what we had originally. X squared plus 6 to the 6th, which is u to the 6th, half du is equal to x dx. So these two are equal. Now this one is much more easier to integrate. So let's just integrate how we integrate any other problem. So the constant just comes over times u to the 6 plus 1, 7. You divide by the new exponent, so that's divided by 7. And since it is just an indefinite integral, we would have to add a c in. But once again, we're not done. Since the original problem was in terms of x, we want the final answer to be in terms of x as well. So what we do is substitute whatever u was. So that's x squared plus 2 raised to the 7th power. And now, since half and 1/7 of u to the 7th is multiplied, we can just multiply the denominators and have 14 and then plus c. And that would be the final answer for that problem. So let's look at this problem now. We have integral of x plus 2 times square root of x minus 2 dx. This time, we don't have something that's the derivative of the other. So the derivative of x minus 2 is not x plus 2. So how do we go about doing this problem? So what we can do is set u equal to what's inside the radical, x minus 2, and then du is just equal to, the derivative of x is just 1, so that's du equal to dx. And the derivative of a constant is just 0. Now, x is equal to u plus 2. So what we can do is rewrite the problem. And since we're using u, we want everything to be in terms of u. So we can't combine x terms and u terms. We want everything to be either in terms of x or u. So since we're substituting u, we wanted it to be in terms of u. So let's rewrite the problem. And on the outside we have x plus 2, and we know x equals to u plus 2. So x plus 2 is equal to u plus 4. And we have radical x minus 2 is just equal to u, so radical u du. So now what we can do with this problem is we can rewrite this in exponential form. So u plus 4 times u to the half du, and then we can just distribute. And we know when we add powers with like bases, we just add the exponents. So this is going to equal integral of u to the, and this is just u to the 1, so that could also be written as u to the 2 divided by 2, and we're multiplying it by u to the half. So half plus 2 over 2, that's 3 over 2. And since we're adding, it's going to be plus 4 u to the half du. Now, the properties of integrals say that if we're adding two terms, we can write it as two separate integrals. So integral of u to the 3 divided by 2 du plus, and since this is a constant, we can write it outside the integral, 4 times integral of u to the half du. Now, this is much simpler to integrate. We can add 1 to the 3 divided by 2, so that's 1 to the 5 divided by 2, and we would divide by the new exponents, and since this is a fraction, we would multiply by the reciprocal, so multiply by 2 divided by 5, add 4 times, since the 4 is a constant, it just comes over, 4 times u to the half plus 1, so that's u to the 3 divided by 2, and divide by the new exponent, so multiply by the reciprocal, and that would be multiplying by 2 divided by 3. And since this is an indefinite integral, we add a c. And now we're still not done. We had the original problem in terms of x, and we want the answer to be in terms of x. So what we can do is substitute whatever we substituted for u. So u is equal to x minus 2. So we have 2/5 times x minus 2 raised to the 5 halves plus, now we want to multiply 4 times 2 divided by 3, so that's 8 divided by 3 times x minus 2 raised to the 3 divided by 2 plus c. And that is the final answer for that problem. Now let's look at a trig example. Now sometimes trig gets a little bit tricky. So let's look at the integral of tangent x times secant squared x dx. Now this might look a little bit intimidating at first glance, but if you have the derivatives of trig memorized, which is this, the problem becomes a lot simpler. So it's desirable to have these memorized. And an easy way to memorize this is to make a table like the one I have here. And remember, all the ones that have c's in the beginning, like cosine, cotangent, cosecant, their derivatives have a negative next to them. And the derivative of sine x is cosine x, the derivative of cosine x is negative sine x, the derivative of tangent x is secant squared x, the derivative of cotangent x is negative cosecant squared x, the derivative of secant x is secant x tangent x, the derivative of cosecant x is negative cosecant x cotangent x. So now if we look at our problem, which one are we going to use? Now we see that the derivative of tangent x is secant squared x. So if we set u equal to tangent x, du is going to equal to secant squared x dx. So that's what we're going to do. So let's say u equals tangent x. Now we take the derivative of both sides, so du equals secant squared x dx. Now we can just rewrite the problem as u du. Now this becomes much more simpler to integrate. We can just add 1 to the exponent and divide by the new exponent. So u squared divided by 2 plus c. So we have u squared divided by 2 plus c. And originally we had tangent x times secant squared x. So we're going to replace u with tangent x. So what this becomes is tangent squared x divided by 2 plus c. And be careful of where you put the squared. Better squared in between the tan and the x. So that means tangent squared x divided by 2 plus c. So that was it for some more examples of U-substitution. So if you have more questions, comment down below and subscribe to our channel, as I'll be uploading more videos related to calculus and AP Physics 1, and also accounting and Excel tutorials. Thank you for watching and take care.